Dear students, myself Vikas, and I am here to do a class on the topic of implicit differentiation. Okay. Now, here in this cases, what we have to do, what all it means is that, for example, we are having a equation like x cubed plus y cubed minus 9xy is equals to 0. This is an equation given to you, and you are asked to find out the differentiation of this question. Now here the differentiation in this case will be that if you differentiate this, you will be having this is you have to put d by dx of y with all the components. Now here it will be like this, d by dx of x cubed plus d by dx of y cubed minus 9 d by dx of xy is equals to 0. If we differentiate 0, it will give you 0 further. Okay, this is 9. Now here this is x cubed, and here in this case we will be having 3x squared. Okay. In the case of y cubed, we will be having 3y squared, and furthermore it will be also d by dx of y, because if you differentiate y, it will give you d by dx of y minus 9. Here in this case we will be having xy in a product form. Therefore, we have to apply the product rule here. In this case particularly, and here it will be like this is the first function, and this will be a second function. In these both the cases, we have to apply the product rule, and you know about the product very well. In case if you are not getting onto the product rule, you can watch my former videos in which I have clearly and absolutely explained the topic of product rule as well as the question rule. Now here, x is the first function and y is the second function. Therefore, I have to put a y first, and I have to differentiate x, which will give me 1. Plus x will come as it is, will be written as it is, and for y, I will be having a y dash, and that is equals to 0. Now here, y dash is the representation of d by dx of y itself. Either we can write d by dx of y, or we can write down y dash. I will be using the term y dash because it is easy to write, and therefore it will be helpful. Now here, I have to find out the value of y dash. Here, then what I have to do, I have to bring all the parts, all that which is having y dash in the LHS form, and all other things in the RHS form. Now here, I will be having this part and this part here. This is 3y square y dash minus 9x y dash. This is question number 1. And furthermore, the parts which are not having the differentiation form, that will be put on the RHS. This is 9y, and this is minus 3x squared. Furthermore, I have to take the y dash common from both these. There will be 3y squared minus 9x is equals to 9y minus 3x squared. Okay. Then how much I will be having? I will be having like this. I can do it here. This will be give me y dash is equals to 9y minus 3x squared. If I be able to take 3 common, I will be having 3y minus x squared. And the denominator part, this will go in the denominator. There I will be having as 3, I will be taking as common. It will be having y squared minus 3x. So this is the required answer. Y dash is equals to 3y minus x squared and over y squared minus 3. So this is the method by which we have to do the questions on implicit function, where the x and y are together, not like this that you are given like this. For example, just solve it, y is equals to sine inverse 2x. Then here the thing is that you have to differentiate the RHS part in the with respect to x, and there the LHS they will be always d by dx of y. But in the case of implicit, they are mixed. They are all together, x and y. There is no differences between them. So we have to use this thing, and we have to make sure that that we have to make d by dx of y into the first part, either in the LHS or in the RHS. Okay. Now let's do some other question is there, and it can be like this. Question number 2, you are having y square plus sine xy is equals to 3x square y square. Let me. Now here, how you will proceed. The first thing which you can do here is first you have to put the sign of differentiation on both the parts, and then there will be a sign of differentiation with individual components. Like this, here you will be having d by dx of y squared, d by dx of sine xy, and d by dx of 3x square y square. Now here in this case, when you differentiate y squared, you will be having 2y, and this is y dash, plus here, if you differentiate sine, you will be having cos y. But here, the angle is xy. You have to then again differentiate xy, and here, the xy is again in the product form. Therefore, what you have to do is, you have to apply the product rule here, and here, if you apply the product rule, you will be having, if you differentiate the first term, that is x, then the y will remain as it is, x will be differentiated to give 1, and then x as it is, and y will become y dash. And here, this part, in this part, you are having x square y squared. Now here, what we have to do is, there is x squared y squared, and here fx is x squared and y dash gx is y squared, then y squared will remain as it is here like this, and you have to differentiate x squared, you will be having 2x plus x squared will remain as it is, and if you differentiate y squared, you will be having 2y, and furthermore y dash is also there, and the bracket is closed. Okay, now the main concern is about you have to switch all the things which are considering the y dash, all this to be put in the LHS part. Now here you will be having 2y dash plus x y dash cos xy, and here you will be having minus 3 to the 6, 3 to the 6, just wait, 3 to the 6, 6x square, you have to multiply it by this, 3 into 2, this is 2, 3 is 6x square y, and the y dash on the LHS part, and on the RHS part, what you will be having is this first term, this is cos xy, this is y cos xy, and this is plus, and here if it goes there, then it have to be here the minus sign, and now here it will be plus 3 to the 6, 6 xy square. Now, now what you have to do is you have to take y dash common. You will be having in the bracket 2y plus x cos xy minus this is 6x square y in the left hand side, and in the right hand side you will be having minus y cos xy plus you will be having 6xy squared. In the later part, what you have to do is you have to find out the value of y dash, and for this thing, what you can do here is you have to just simply write y dash is equals to minus y cos xy plus 6xy squared, and in the denominator there is 2y plus x cos xy minus 6x squared y. These are the whole thing which will be keep clear to you on doing questions. Okay, fine. Let's do some more questions. We can see that what you are having is very simple question is there. You are having x squared over a squared plus y squared over b squared is equals to, this is the equation of ellipse, and you are here to find out the value of, you have to find out the differentiation. Okay. Now, if you have to differentiate it, you have to put the sign of d by dx of both all the elements. This is d by dx, and here this is d by dx of it. Okay. Now, if you differentiate it, what you will be having, now this is a square, the constant term, it will remain as outside term, and you have to differentiate x square, which will give you 2x, plus here you will be having 1 over b square, and when you differentiate y square, it will give you 2y, and it will be y dash is equals to 0 if you differentiate d by dx of 1. Okay. Now, What you have to do is you have to bring back, now you have to bring this y dash on the LHS part. It will remain as it is. This is like this 2y over b square. And this whole term of x will go there. This will give you 2x over a square. Now this both the two will cancel out. And here if I write it, it will be like this. Y dash is equals to, I have to take this b square on the upper side. It will give you minus b square over a square. And this y will go below the x. And here this is x over y. This is the required differentiation of this very part. Okay. Now say student, there are two questions. Questions are easy. Let's do it. These are the implicit functions, and you have to find out the value of d by dx of y. Now here, if you differentiate both the sides, I'm directly differentiating it. I'm not putting the sign of d by dx. You have to put them. On differentiating, I will be having twice x plus y, and then I have to apply here the chain rule. I have to differentiate x plus y. This will give me 1 plus y dash. If you are facing the difficulty in applying the chain rule, you can go through the videos of mine, which are there. Okay. Now here, this is 2 minus 3y. And on differentiating 2, it will give you 0. And for minus 3y, it will give you minus 3y dash. Okay. But we have to find out the value of y dash. First thing what I have to do is I have to multiply these things. I can take this 2 from out from here. I can put it here. Okay. Now multiply it. I will be having x plus x y dash plus y dash. Okay, I have to multiply x by both these things or y by both these things. Okay, okay. Now this is x plus xy dash plus y dash is equals to minus 3 over 2 y dash. I have to bring y dash onto the LHS part and I have to take common. Therefore, I will be having y dash. From here, this is x. From here, this is y. And from this will give you plus 3 over 2. And in the RHS, these two will go into part of RHS. I will be having minus x plus y. Now the answer will be y dash is equals to minus x plus y whole over x plus y plus 3 over 2. Okay, these are the simple questions which you can. Now, there's another question. This is x is equals to under root 2x square minus 6y cube, and you have to first write down the differentiation, the d by of dx. You have to write down yourself. Now here I am differentiating it. On the LHS part, there is simply x. X will give you a 1. And on this first you have to differentiate the square root. You will be having 1 over 2 under root 2x square minus 6y cube. 1 is equals to 1 over twice under root 2x square minus 6y cube. And this here again, I'm applying the chain rule. You have to make it notice that where we have to apply the chain rule. Now here, what you have to do, you have to differentiate this in everything which is inside the square root. And here this is 4x. 2x square will give you 4x minus 3, 6, 18, 18y square. And furthermore, you will be having y dash because d by dx of y is same. Okay. Now we need to find out the value of y dash. The first thing I can do is I have to bring this on this square root on the upper side. Then while putting it here, I will be having twice under root 2x squared minus 6y cubed. And in this side here, I will be having, first I can do the common part. This is 2, I can take common. If I take common, I will be having 2x minus 9y squared y dash. This 2 will be cancelled by this. Now, furthermore, I have to put this, no, okay, I can take this back. I can bring here 9y squared y dash, and I will take this square root part whole of the RHS part, which will be equal to 2x minus square root of 2x squared minus 6y cubed. Okay. Now, I have to find out the value of y dash, which will be equals to 2x minus 2x squared minus 6y cubed and whole over is 9y squared. This is the required answer for the part. Okay, I'll just do some more questions. Now let's start with some more questions. For example, you are having a question like this. You are having tan inverse x squared plus y squared. This is a square and is equals to 7. Okay, this is the question. This is tan inverse x squared plus y squared is equals to 7. Now, first thing, you have to write down the sign of differentiation d by dx on both the side. On the what we call as LHS, but don't do this 7 because it will give you 0. So what else you can do here is you can put here as x, let it be x. Okay. Now, if you differentiate it, the first thing is which you must know, the thing is that d by dx of tan inverse x is equals to 1 over 1 plus x squared. Okay, you must know about this. Now, what happens here is that this is here first you have to apply the chain rule here, and you will be having 1 over, this is 1 plus, and this is a whole part is x, which is x squared plus y squared whole power 2. Furthermore, you have to differentiate this part, which is x squared plus y squared, and it will be equals to how much? It will be equals to how much? It will be equals to how much we will be having 2x plus 2y y dash. If you differentiate x squared, you will simply have at 2x, and if you have to differentiate y squared with respect to x, you will be having 2y, and then you have to differentiate y, which will result in d by dx of y. Furthermore, in the RHS part, you are having 7x. 7x means you will be having 7. Now, what else you can do? You have to first you can do the thing is you can bring this 7 this denominator to the RHS part. In the numerator, you will be having 2x plus 2y y dash, and in the RHS you will be having 7, 1 plus x squared plus y squared, and the whole square is there. Now you are having y dash here. Y dash 2y y dash, and here it will be that 7 bracket 1 plus x squared plus y squared whole square, and this will go into this part minus 2x, and in the next step what you can do is you have to find out the y dash, therefore you have to put 2x in the denominator of this part. Okay, clear? Let's start with something new. Now we have to do another question. And what the question is, how you can write this question is, let you are having log x squared plus y squared is equals to tan inverse x over y. You are having this question. Okay. Now, what you can do here is, the first thing is you have to apply the formula for here. This is d by dx of this part and d by dx of this. Now, we know the differentiation of log x, d by dx of log x is equals to 1 over x. Okay. Now, when we apply it here, I will be having 1 over x squared plus y squared. And furthermore, I have to apply the chain rule because this is not x, this is x squared plus y squared. I have to differentiate this. I will be having 2x for x squared. And when I have to differentiate y squared, I will be having 2y. Furthermore, there is a y dash. Okay. Now, this is the part which I've done in the LHS part. Now, come on to the RHS part. We know that tan inverse x is equals to 1 over 1 plus x squared plus y squared, which I've told you in the previous question. Now, here I will be having 1 plus x over y whole square. Now, furthermore, this is basically not x over y. This is a question rule here, which I have to apply. Now, here, when I apply the topic of question rule here, the denominator will be y squared. And in the numerator, you know that you have to put the gx, which is y here as it is, and you have to differentiate the fx, which is x here. You will be having 1, then you have to put a sign of negative, then x will remain as it is, that is the first function fx, and you have to differentiate the lower function, which is gx, and here this is y, which will give you y dash. Okay, now what you can do further is, now here what you have to do is you have to solve this part, and now solving this part I will be having this is the base, this is 1, and in the denominator you will be having y square plus x square, and in the denominator there is y square. Okay, but this y square will go on the upper side, as you know it. Now here it will get multiplied by 1 and it will give you y square. Then I can remove all these things. Now I have to remove all these things. Just wait. I have to remove all these things. Okay, now this is left with us. Okay, now the denominator in the this part, I will be having y minus x y dash over y square. This y square will get cancelled out, and here you will be having 2. I can take common. Now here it will be x plus y dash, and in the denominator you will be having x square plus y square. Okay, now here this is x square plus y square. Now these two will get cancelled. These two things will be cancelled out. Clear? Now what will be remaining here? What will remain here? I have to find out the value of y dash. So what I have to do is I have to just do something more, because there is y dash on both the sides. I have to bring the y dash on one particular part. Let's erase out these topic, these steps which are now further in the use. And after doing all these things, what I will be having in, okay, just wait. Just wait. Now what I will be having is, this is 2x plus 2y dash is equals to y minus xy dash. Okay, this will be there. Now here I have to bring y dash from both the sides onto the LHS. Now here this will be 2y dash plus xy dash, and this 2x will go there. This will become y minus 2x. Now I will take y dash common. You will be having 2y plus x in the bracket, and here y minus 2x. Therefore, the required answer for y dash is equals to y minus 2x, and in the denominator this is 2y plus x. Okay, this is the required differentiation of the given question number 7, which is log x squared plus y squared is equal to tan inverse x over y. Okay, let's start with another question, and what the question is now saying to us. You are having a question with us. Now let's do a question. Okay, you are having y is equals to x sine a plus y. This is a question. Y is equals to x sine a plus y, and what you have to do is you have to find out the value of y dash, which you have to prove actually, which is sine square a plus y. Okay, and in the denominator you will be having sine a plus y minus y cos a plus y. This is the required solution which you have to find out. Now, here in this type of question, you are seeing that you have to find out the value of sine square. You have to find out you require sine square a plus y. Now, one thing in the differentiation you must note it, that if you are having x raised to the power n, the power will get decreased for by 1. Okay, if you are having x raised to power 7, and on differentiating it, you will be getting x raised to 7, x raised to power 6. Okay, power is decreased. But if I put like this, d by dx of 1 over x, it will give you d by dx of x raised to power 1 minus 1. And if I differentiate it, it will give you minus 1 over x square. If the power is negative, the number is in denominator, then the power gets increased by 1. Okay, clear? Now come to the point here. Why I have said of this story here in this particular question, so as make you learn the meaning of the method which we have to adopt. Now here in this case, what is the main question? You don't need x at all in this part. Furthermore, you need sine square a plus y. Then simply what I can say here is y over sine a plus y. I can write it down, and which is equals to x. Y over sine a plus y is equals to x. Now, what we can do? we can just do the differentiating part. Now here, if I differentiate it here, then you will be having x is equals to 1. Okay. And now here, what I can do is, that I have to differentiate it. And here in this case, first thing I will be having is I have to square the denominator. And furthermore, in the numerator part, I have to put the denominator part as it is, sine a plus y, and I have to differentiate the first part, which is y here, which will give me y dash. Then there is a minus sign. Then furthermore, now what else? Now what I have to do is, now I have to put y as it is, and I have to differentiate the denominator part. Denominator part here is sine a plus y, and it will give me cos a plus y. Furthermore, there I have to apply the chain rule, because here the angle is not x, angle is a plus y. Now, if I differentiate this and with the help of the chain rule, I will be for a, I will be having 0, and for y, I will be having y dash. And here, when I differentiate x, I will be having x is equals to 1 on differentiating. Now, what I can do? First thing I can do is I have to bring the sine square a plus y to the RHS. Okay. And now here, what else I can do is I can take y dash common. On taking the y dash common, I will be having sine a plus y minus y cos a plus y bracket close. This is sine square a plus y. Now, what I have to do is I have to find out the value of y dash, and for this, y dash is equals to sine square a plus y, and in the denominator, I will be having sine a plus y minus y cos a plus y. This is the required answer and what we have to prove for question number 8. Okay. In this way, you can do all the questions of implicit form and many questions of the implicit form. Okay. Let's do some more questions. This is question number, just stop. This is question number 9. Now, what this question number 9 says to us, for you are having y and y under root x square plus 1 is equals to log under root x square plus 1 minus x. This is a question. Okay. And here again, the thing is, you have to prove it. And what you have to prove it? You have to prove that where the question is lost. Where it is lost. X square plus 1 y dash plus xy plus 1 equals to 0. This is the question which you, this is the equation which you. The main thing, as you saw the question given, and what you have to prove, the first thing is there is no log in the equation which you have to prove. The first thing is you have to make sure that there is no log. It means what you can do is then you have to make it remain as it is, as the question is. You have to simply differentiate this question. Okay. Because if you take anything with log, then the log will come into the existence. But here, on differentiating this equation, you will be not having the log. Okay. Now here, this is fx and this is gx. There you have to apply the question, or this you have to apply the product rule. Fx is y and gx is root x squared plus 1. You differentiate y, you will be having y dash, and under root x squared plus 1 will remain as it is. Furthermore, when we put y as it is, and you have to differentiate under root x squared plus 1, this is twice x under root x squared plus 1. And if you have to differentiate x squared plus 1, you will be having 2x. Okay. Now here for this part, now here this is log x, and if you differentiate this log x, you know that it will give everything in the denominator. You will be having x squared plus 1 minus x. And now by using the chain rule method, you have to differentiate the all internal part, that is all this part. While differentiating this, you will be having 1 over twice under root x squared plus 1. And on furthermore, if you differentiate x squared plus 1, it will give you it will give you 2x. It will give you 2x. And for the root minus x will give you minus 1. Then both 2 will get cancelled. Okay. Now what else you can do here? What else you can do here is you have to just where you two are having the y dash. Only in this part you are having the y dash. Furthermore, what you can do is first you cancel out this 2, just like this you have cancelled this 2. And in the LHS part, what you have to do is you have to take the LCM. You can put write down 1 here in the denominator. You will be having under root x squared plus 1. And you have to then multiply this. You will be having y dash x squared plus 1 plus xy from this. Okay, now come into this part. This part, you are having 1 over under root x squared plus 1 minus x. And what is here? Here, this is 1. And if you take the LCM here, you will be having under root x squared plus 1. Whereas here, you will be having x minus under root x squared plus 1. I think everything is clear to you. No doubt. Any questions? Clear? Now, what else you can do? The first thing you can do here is you can cancel out this x squared plus 1 with this x squared plus 1. The first thing you have done. The second thing, what you can do here is this whole part, this numerator part, and this part is same. But there is a difference of minus. Yeah, it means when you cancel these both sides, there will be minus 1 left, not 1 left, because of the negative sign. Okay? Now, the thing is what you are having. Now, what you are having for this, I have to erase some of the part, and now I'm trying to erase this out. Okay? Now, after erasing all these parts, okay, now I will erase this. Now, come on to the point. Now, what will be the answer is this is x squared plus 1 times y dash plus xy, and this is equals to there is minus 1. In the next step, what you will be having, this is x squared plus 1 y dash plus xy plus 1 equals to 0. This is the required answer. Okay. Now we will do many of the questions. Furthermore, just I'm writing one more question here in this. Now here the question is that y is equals to log sin x base cos x times log cos x base sin x whole inverse plus sin inverse 2x over 1 plus x squared. You have to find out the value of y dash at x is equals to pi over 4. Okay. Now here what you have to say here is first thing how you can solve all these things. Okay. Now I'm just be giving you some of the things which you can use here to help yourself. Now here, what is the whole thing is? Now here, if you are having log a base b, and this can be rewritten as log a over log b. Okay. Now here, if you see this, you are having log sin x over log cos x times. Now here, it will be like log cos x over log sin x, and furthermore there is power minus 1. The further this can be written as log sin x over log cos x, and here this is again written as log sin x over log cos x. There means it is log sin x over log cos x is whole square, which can be written as log sin x base cos x whole square. Okay, this is a simple explanation which I want to give you. Understand it? Okay. This is the reason why I will be writing all these things. The second thing is I have to write down about sine inverse 2x and all these things. Okay. In the second part, you are having sine inverse 2x over 1 plus x square. So what it means is that you are having sine inverse 2x, I can write to tan theta over 1 plus tan square theta, which will be equals to sine inverse sine 2 theta. Furthermore, this 2 theta, sine inverse sine 2 theta is equals to 2 theta. And furthermore, this 2 theta can be written as 2 tan inverse x. Why so? Because I have put x is equals to tan theta, and therefore theta is equals to tan inverse x. Okay, all the things is clear to you. So what I am going to write here is, see here. Now what I can write here is this is y is equals to log sine x base cos x whole square, and here this is 2 tan inverse x. These are the two things which I'm having here. Okay, clear? Now, what I can do here is, the first thing what I can do here is I have to differentiate both the sides. On differentiating both the sides, you can write it on differentiating both the sides. I will be having y dash is equals to 2 log sine x base cos x. And then what I have to do here is I have to differentiate this d by dx of log sine x over log cos x. Okay, I have to differentiate it. Now, after doing this, furthermore, here in this part, what I have to do, I have to write it twice 1 over 1 plus x squared. Okay, this is the total thing which I have to do. Clear? Now, here I have to apply the quotient rule. This will give me twice log sine x base cos x. And here on applying the quotient rule, I will be having log cos x whole square. In this part, numerator part, I will be having log cos x. And I have to differentiate this upper part log sine x. I will be having the denominator sine x. And in the numerator, I will be having cos x. Because I will apply the chain. Further, there is a negative sign. And after this, I have to write down as log sine x. And furthermore, I have to differentiate the denominator part, which is log cos x, which will give me in the denominator, this will be cos x. In the denominator, when I differentiate cos x, I will be having minus sine x plus 2 over 1 plus x squared. This is the whole thing which I will be having. Okay. Now, what else I have to do? I have to just differentiate this part, and I have to just put the value actually I have to find out the value of y dash at the x is equals to pi over 4. Okay. Now what else I can do here is I can convert the cos over sine as cot and sine x over cos x as cot. I can do all these things, but the main thing is I have to find out the value of cos pi for one of the differentiation y dash is equals to for value at x is equals to pi by 4. For this, I know one more thing, that for value of sine pi by 4 is equals to cos pi by 4. And this is equals to how much? For cos pi by, oh, sorry, sine pi by 4, I will be having 1 over under root 2. Okay, you must know it. Now here, then y dash is equals to how much? Y dash is equals to twice log 1 over root 2, and base is again 1 over root 2. In the bracket, I will be having log 1 over root 2. And when we are having cos over sine, it will give me 1. Okay. This minus and this minus will become plus. In the bracket, I will be having log 1 over root 2. And then again, sine over cos will be same. It will give me 1. In the denominator, I am having log cos x. It will give me log 1 over root 2. Whole square is there. And in this part, I will be having 2 over 1 plus pi by 4, and the whole square is there. Okay. Now here, you know y dash is equals to log m, and base m is always equals to 1. Okay. Now here this is twice, and this whole will convert into 1. Okay. In this part, in the numerator part, there is log 1 over root 2. Okay, there is log 1 over root 2. Just wait. Log 1 over root 2. And what and here this is again log 1 over root 2. Here's 1 again 1 over root 2. Then it will become 2 times log 1 over root 2. And in the denominator you are having log 1 over root 2, and this is a whole square. Therefore this whole will cancel out 1 time square. Okay, now here you are having here this 2 over, this is 4 square, it will become 16, and 16 will go upwards. And here this 4 will multiply by this is become 16, and this will give you 16 plus pi square. Fine. Now what else we can do here is, now what else the answer will be? Now the answer will be, this is 4, y dash is equals to 4 over log 1 by root 2, and this will, if I take it up, this will give me log 1 by root 2 whole raised to power minus 1 plus 32 over 16 plus pi square. Okay. Now what happens here? This is y dash, and y dash is equals to this what we call this power is minus 1. Then this will become 1 over, this will become 4 times log root 2. Okay. If you are not getting the point here, you can see here you are having log 1 over root 2. Okay, and this is whole is the power minus 1. Okay, now here it will become log 1 over log root 2. Okay, this is power minus 1. Okay. Okay. Now what here we have to do is we have to solve this part, log 1 over root 2. Now I'm helping you to solve this. This is log 1 over root 2. And it will give you log 1 minus log root 2. Okay. Furthermore, we know that the value of log 1 is equals to 0. This will become 0. You will be having minus log root 2. Then you will be having minus log 2 raised to power half. It will give you minus 1 by 2 log 2. This all is in the denominator part. Then you are having y dash is equals to 4 over minus 1 over 2 log 2, this, and plus 32 over 16 plus pi square. Okay, just wait. Now what I can do here is I can take this 2 on the upper side. Therefore, it will give you y dash is equals to minus 8. 2 will get multiplied by 4, and denominator is log 2 plus 32 16 plus pi square. I can take 8 common, then I will be writing as 4 over 16 plus pi square, and this is minus 2 over log 2. This is log, just wait, this is log. Okay, we're having log 2. Okay, this is the required answer of this particular question when differentiated at x is equal to 4. So students, be there and join me, subscribe me on my videos to make sure that you should get all the good content of studies. And now we are on the topic of differentiation, which is said to be the implicit differentiation. Thanks for watching the episode. Bye.